Hi there, I'm Hao, and it is just another video of me solving randomly code problem. So today we have rotate array. Given an integer array nums, rotate the array to the right by k step, where k is non-negative. So if we have 1, 2, 3, 4, 5, 6, and 7, we can rotate right, which means go this way, right? Put the 7 to here, right? So on and so forth. Then the 6. So this is one time, right? Two time, right? And then three times. The five still here. We could give us 5, 6, 7, 1, 2, 3, 4, right? So inserting an element in the front, it was a very bad time complexity. It's linear, right? And we need to do it n times so n square because every time we put an element in the front, we need to reassign the indices, right, of the array. And we have to do it in place. We know k is non-negative, so that is a good thing to know. And we also know that the num should be at least one element. Okay, so how could we do this? If we have the um, so let's talk about k. So if we have this array 1, 2, 3, 4, 5, 6, 7. If we rotate 7 times, right? So 7 go here, 6 go here, 5, 1, 2, 3, 4, 5, 6, 7, right? No, sorry. If we rotate 7 times, then 7 will go here, right? 7 will go here. Actually, let me just write it out so you can visualize it. So 7, 1, 2, 3, 4, 5, 6, right? It is 6, 7, 1, 2, 3, 4, 5, and it is one time, two time, 5, 6, 7, 1, 2, 3, 4, and then 4, 5, 6, 7, 1, 2, 3, right? This is the third time, fourth time. The fifth time would be 3, 4, 5, 6, 7, right? 1, 2, right? And then 2, 3, 4, 5, 6, 7, 1. The sixth time, and the last time would be 1, 2, 3, 4, 5, 6, and 7, right? So if we rotate, so if k is 7, right? We rotate k time. Uh, if k is 7, then it would go back to the original array, right? So if k is let's say k is 8, right? If k is 8, then we don't want to rotate 8 times, right? Because it take up too much time. Because we know that because we know that every time we rotate num dot length time, then we know that we will get back the original array, right? So at any point in time, we only need to rotate k mod the num dot length time, right? If k is like 6, if k is 7, we will have the same results, right? As k is equal 14 or 28, so on and so forth. So we always want to mod the k by the length of the array, so we don't have to repeat ourselves. Right. Okay, so that is the first thing. Okay, and then we can see that every time we rotate k times, right? If we want to rotate k times, I can see that we have to swap the element like this, right? It's feel like swapping 6, 2, and then 5, 3, 5 and 3, right? Which just look like almost the same at the original at the resulting array, right? Except that the 4 here is not in the correct place. So what if before we even do any swapping, do any rotating, what if we reverse the original array first? So 6, 5, 4, 3, 2, and 1, right? If we rotate the array first, then we can see that if k equals to 3, then this is 5, 6, 7, and it is 4, 3, 2, 1, right? It is 1, 2, 3, 4. So if we reverse this and reverse this part and this part, we would have 5, 6, 7, and 1, 2, 3, 4, right? Which match with our output here. And what is this cutoff? This cutoff will be k, right? K minus 1. If you want to talk in terms of index, then it is k minus 1, 0 to k minus 1, right? And it is on the left side. So 0 to k minus 1. And this part is k to the length minus 1, right? The length minus 1. All right. So if we reverse this part, we would have the correct output, correct result. If we reverse the array at the beginning and then reverse the two part, then we will have the correct result. And doing this way, we would only, our time complexity would only be linear, right? So that is better. And I don't think we need to use any extra space to do this. So the space would be constant. Okay. So let's code this up. So first thing first, remember our k has to be k mod num sub length, right? Because we don't want to repeat ourselves, as I mentioned earlier. And then we want to reverse the array first, right? Reverse from 0 to num sub length minus 1. Let's create a reverse hyper method. Type in the left and the right, right? And we can just keep swapping. Right, 1, 2, 3, 4, right? If we swap this one and this one, and then this one and this one, right? We'd have 4, 1, and then 3, 2, right? Which is correct. And then when the left and the right, right, overlap, then we know that we are finished reversing. Okay. So y left is less than right. Then we want to swap, right? Left and right. And then we want to increment the left and decrement the right, right? So left moving right and right moving left. So let's create a helper method for swap. Let's plug in the index 1 and index 2. Right. M equal to num set index 1. Num set index 1 equal to index 2. Num set index 2. And then num set index 2 equal to 10. Right, so it is the swapping function. So y left is less than right. We just keep swapping the left and the right. The left keep moving left. Sorry, the left keep moving right, and the right keep moving left until they are overlapped. Okay. So now we finished reversing our first our array. That's the first step. The next step we will need to reverse remember reverse the two subarray, right? The first subarray will be 0 to k minus 1. Here, 0 to k minus 1. And the second part is k to the last index, right? So reverse from 0 to k minus 1. And then reverse from k to the last index, and then that length minus 1. Okay, so that's pretty much it. Let's give it a try. Accept it. And thank you for watching.